About trisecting a line segment, which in the past we did something called bisecting or finding the midpoints. There is a way for us to actually do a trisection of any line segment possible. But let's go ahead and set it up. I am going to request that you probably actually do some of this with me in another piece of paper. You should have all of what you see here with a compass, highlighters, pens, pencils, even colored pencils, just to add that extra bit of flair. Now, I highlighted some key words. I hope you see them as well as we work, and I even gave you the answer for number 1. So pause the video, write down the sentence, but then come back and listen to or think about it as you're writing it down to why it is. Don't end the video because the worked example we're going to actually do on this extra paper, okay? So pause, write, and then I'll keep talking about it. Go. I'm assuming you paused it. So let's go. Setting up a proportion to show the line drawn parallel to BC divides AC into a 1-to-1 ratio. In that one of them is over there, that's that one, and one of them is over there, that's the other one. When we talk about trisecting a line segment, we're going to talk about the ratio that's given. It won't be 1-to-1 because that's for midpoints, or bisecting. But if we have a trisection, we're going to be thinking about maybe like 1-to-2. Now let's talk about this one. We have this mid segment. We have a parallel line to BC. We found the midpoint. We found equal sides. Let's actually do what it is for not a bisection, but for a trisection. Trisect DE by dividing its length into thirds. That's the objective. That's the goal. Boom. I could say that on a test. By the way, if you're going to say I'm going to fail this test, you've already committed to it. You said that, and now you're probably going to fulfill that prophecy. Why don't you do something different about it now? Draw an auxiliary ray, that's the blue line here, using one of the endpoints of the segment as the endpoint of the ray. Let's do that. In fact, I'm going to use a black pen for DE. I'm going to use the straight edge to make sure that I'm drawing a straight line. Somewhere near the top of the paper, I guess. And I don't know, I drew it approximately 3 inches, 2 inches long, maybe 2.5. About that big. Now I'm going to bring in blue because that's what's on this page in dotted line. And it doesn't look like they really care about how big that angle is. So if I just kind of span it down this way, and then I'm going to use a dotted line though. Boom, 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 boom. Try to mirror what the book is. Because the book says something on the directions here. It's a really good idea just to confirm the directions are sensible, like they actually work. And this should give us the entire picture of this entire worked example. So check it off. We've got that part. We've got that part. Using a compass, select an arbitrary length and duplicate that length 3 times, starting at the end point of the ray. So this is considered the end point of the ray. And I've got this compass, and I think what I'm going to do is I'm going to use I have the compass from the previous video. I got it shoved all the way up into the center of the circle, and so I'm going to use that as my marker. I've got the end point of the ray where my compass is, and then I'm going to pin it and spin it. Now that location is capturing just that distance, so I'm going to do that again. But the center of my compass is now on that intersection. Same circle. Okay, there's that one. One more time so I can have the ray marked at 3 line segment amounts. 1, 2, 3. Okay, check. And yeah, it looks like that. Okay, label each equal distance between 2 consecutive points on the ray as X. Oh, like that. X, then X, then X. They also put dots there, so I'm going to do the dots as well. So I've got a dot, and I have X. Then I have another dot, and I have an X. And then I have my third dot, and I have X. So that part is done. Connect the third point F. Why is it F? Oh, because they put it on there. They actually labeled that third point. So this third point is going to be called F. Okay, that's done. To the opposite end of the original line segment to create triangle DFE. Okay, I got to make it into a triangle DFE. So I'm going to make F to E connect. And I think they say draw it like a solid line. Again, I'm only using the blue pen now. Maybe I'll bring in the red pen in a minute, because on the example, DE is still a black line, while all the rest of these constructions are done in a different color. And 100%, that step is done. Now, draw parallel lines to side EF through the points on side DF. So parallel to this, through those points. What's the best way? I could use the compass. I'm going to use tracing paper for this. I think the tracing paper is actually going to allow me to preserve the angle, because that's what it is. I'm going to make an angle here, and then I'm going to make another angle here and another angle here, and they're going to be corresponding angles. And if you have corresponding angles that are congruent, you've created parallel lines. So maybe tracing paper and pencil is the appropriate construction tool now. So creating parallel lines. I'm going to trace FE, and then I'm going to trace DF. Now let me show you a trick. If I did this right, I should be able to flip the tracing paper over, because the angle will stay the same no matter if there's a reflection or a translation or a rotation. So I'm going to flip it over, that way the graphite is on the other side of the paper. And now I'm going to slide so that this line stays on side DF. And I'm going to slide it up to there. There it is. Look at that. Okay. Then I'm going to trace over it. And I'm tracing that pencil and pushing it onto the paper. I should trace a little longer. Go over across it. We got 2 of them to do, so that's the first one. And that's the second. Yes. Oh, it looks beautiful. I love it. I love it. It's exciting to see the mathematics work out perfectly. I'm going to bring in a red pen now, because different color is helpful. I'm going to trace this. I'm going to slide up here and trace this. And then label the distances between parallel lines along DE as A, B, and C. Like A, B, and C. Okay, so this is A, this is B, this is C. Check. Okay, use the triangle proportionality theorem. The proportions of A over B is equal to X over X. And B over C is equal to X over X. So therefore, this A and this B and this C are all the same distance, because X was the same as X was the same as X. Yeah, we did it. We trisected the line into 1, 2, 3 equal sections. This could be considered a 1 to 1 to 1 ratio. Or if you group 2 of these at a time, it'd be a 1 to 2 ratio because of how we grouped them. Trisecting, 1 to 2, done this way. Expect that I'm probably going to ask this on some sort of end of quiz, end of lesson check, and then you're practicing this as well. So have your tracing paper, have your extra paper, have your compass, have multiple tools to let you draw and capture them. Thanks for watching this video. This has been page 521. Up next is page 522, where I'm going to ask you to do a longer sort of section. So thanks for watching. I'll see you in the next episode.